Hello, this is Bruce. It is November 15th, 2022. I just turned on my device. I have to put this onto watts. So I've got, looks like 4.2 watts going in. I hope you can see that. And let me turn on the voltmeter and the amp meter, and those are both pinned out. That's what it is when it's pinned out. So that's on the highest volt reading for DC, and this is on a 5 amp reading for amps. I'm going to use this one to read the capacitor. This is a 450 volt capacitor, 220 microfarad. So this will hold 450 volts. This is a 9-volt battery. It's used. Starts out with at least 9 volts in it. This is an LED that is 3 volts and 0.03 amps to run that. Here's my system, the ZC technology. It's on glass again, so you can see there's nothing under it. It is plugged in to this, which is a DC power supply. Goes into the bottom. Now this white and black wire are connected to the output, and I'm going to use these to fill up the capacitor to show you a neat test that these are real volts and amps that I'm getting out of my system. There we go. Show you that there is enough power to run this little motor. You can probably only hear it. I don't know if I can get you to see that. So that's a 9-volt battery running a little DC motor. Okay. So when I touch the battery to get a reading, the voltmeter shows that those are the volts in it. Okay, when I touch the capacitor, hook these on the capacitor. I thought it discharged it. It's discharged now. There's nothing in it. Now, this 9-volt battery can only put 9 volts into the capacitor, even though the capacitor could hold 450. Doesn't matter how long I keep it on here, it's only going to be 9 volts. Or thereabouts, whatever's in the battery. Okay, I cannot put a lot more in there just because I'm holding it on here longer. This is part of the point that I want to make. So I'm going to go ahead and discharge this. Maybe you'll see a spark. You heard a little click. Make sure this is empty again. Empty. Now, this is the neat part. So these are the leads that are coming off of the power. You can see, I showed you earlier. This is the positive, this is the negative, and this is the power coming out, so you can also keep an eye on that, hopefully. All this stuff simultaneously. So the light glimmered a little bit, and as you can see, this is filling up the capacitor. We're up to 68, 69, 70, 75, 80, 85, 88, 90 volts. Back here you can see there's still 12 volts and a lot of amps, and we're at 3.9 watts. So I'm over 100 going in to this at this point. I'm going to move this over here. I'm going to go ahead and disconnect this. So looks like there are 103 volts in there. Go ahead and disconnect this just to prove that they're in there. I'm going to discharge it. This is the scary part. Ooh, nice spark. Okay. Now, it's a pretty big spark. Get my leads all in the right spot here. Excuse the confusion. I get a little nervous when I discharge the capacitor. It's a super capacitor. Let's see what's in it. If there's anything else left in it. Pretty much discharged it, except for about 4 volts. So let's pick it up from here. So that's down to 0. So let's do that one more time. I hope you saw what the readings were here. This time, since we're going to load it up to about 250. That way you can do the math with the watts, 4 watts or whatever the watts are, divide by 250 or maybe 300 volts. You'll see how many amps it would take to equal the volts. And you can read what's on here and see what's also running in here and realize that, yes, indeed, I am getting more power out. So here we go with this experiment one more time. Battery. So you can see this is up to 60. That's 3.8 watts coming out of the wall that I'm using to power the whole thing. So far I've got 12 volts left over, 14, and 0.03, 04, 05 microamps there left over. This light takes milliamps. This is 3 milliamps for 30 microamps. 0.30 of an amp. So it kind of fluctuates. So right now I am at $120. If you look at the meters in the back, this is still at very high. This is very high, and that's at 4. This may take a second. Seems to be slowing down. whole point is to show that these are real volts coming out of the unit. There's 130. Should be a pretty big pop. Still climbing, just slower. As you remember, the battery would not continue to increase. I could turn it up a little bit if I wanted to really get it up there. But as you can see, these connections are all pretty unprofessional using these clips. This is probably taking enough of your time. We'll get it up to what, 135 volts. This says this is pinned out, this is pinned out, and that says 4 watts. There's 135. So I'm going to stop at this point. So pull it out. We are at 130 volts in that capacitor. Let's go for the pop. There you go. So there's some power there. So you can take 4 watts going in, since amps times volts equals watts. You go, let's use 4 watts, divide by 135 volts. That would be 0.029 amps going in. We saw that I had more on here. So, plus what's burning here, plus the length of all these wires. This is DC power, so it takes a while. The longer the wire, you get drainage. That's why we transmit electricity in AC versus DC. Thanks to Nikola Tesla. Alright, there's the scorch marks. Alright, thank you very much for your attention. Once again, it's Bruce. It is November 15th, 2022, and this is ZC Technology.